In our previous video, we discussed about the site-to-site VPN and GRE tunnel with the help of IPsec to provide the security. But there are so many issues in the GRE tunnel and site-to-site VPN as well as in the IPsec over GRE. Let's talk about all the issues. Okay. If only talk about the traditional site-to-site VPN, what are the issue in that? The problem with the site-to-site VPN is that we have to create a VPN tunnel in between the two routes, right? When the company has more branches or offices, the number of VPN tunnel will be increases and that number will be n into n minus 1 upon 2. Let me explain you with the diagram. Let us observe this diagram. There are only 4 branch offices and sharing the internet via ISP. Okay. So 4 branches are there. 1, 2, 3, 4. If we are going to do the configuration of site-to-site VPN, even for the GRE tunnel, what will be the issue? The major issue is that we have to connect every single office with the other offices and has to create a tunnel in between them. So if there are 4 offices, we have to create 6 tunnels. In 4 offices, we have to create 6 tunnels. Here we can see branch 1 is connected to branch 2, branch 2 is connected to branch 4, branch 3 is connected to branch 4, and branch 1 is connected to branch 3, branch 3 connected to branch 2, and branch 1 connected to branch 4. So here we can see that the total number of tunnels will be n into n minus 1 upon 2. Here we can see. So what will happen if the number of offices will be 10? If the 10 number of offices will be there, then what will be the issue? Okay. Let me draw. Okay. This is office number 1. This is office number 2. This is office number 3, 4, branch number 5, 6, 7, 8, 9, and 10. If there are 10 branch offices connected via an ISP, okay, so what will be the issue in this kind of network? When we do the configuration of IPsec VPN or GRE tunnel VPN, the issue is that we have to create how many tunnels? 45 tunnels in these 10 routes or in these 10 offices. That is means we have to create the tunnel for 45 times as well as we have to provide the encryption on all the 45 tunnels. And dear, this is really a big issue. It is not easy to create 45 tunnels as well as to encrypt every single tunnel. There will be a very long configuration. And let us assume if we have 50 offices or 50 sites, then the total tunnels will be 1, 2, 2, 5. So we have to create this number of tunnels as well as we have to maintain the records. And also the major issue is that we have to do the encryption for all of them also for IPsec. Okay. Another problem is that if any change in the IP address, let us assume the branch office 1 has changed the IP address. The problem is that all the tunnels connected to branch number 1 will be goes down. And we have to do again and again configuration for the new IP addresses. So we can't use the dynamic IP address in this kind of problem, in this kind of configuration. In case of site-to-site IPsec VPN or GRE tunnel configuration, we can't able to do the configuration over the dynamic IP addresses. So the problem are major problem as we have seen, it is a complex configuration, difficult to manage, and large number of IPsec policies will be needed because the number of tunnels are very high And also we are creating one-on-one tunnels separately. So all time we have to do the configuration of IPsec policies also. Now, let's talk about the troubleshooting. If these number of tunnels will be there, the data maintaining should be will be very hard enough. Also, the troubleshooting will be very hard. Okay. Now, let's talk about the issue with GRE tunnel. Dear, the issue will be same now. So what will be the issue? The first problem is that it doesn't support uh, issue with the GRE. Let's talk about the issue with the GRE tunnel. The GRE supports multicast, broadcast, as well as dynamic protocol. So these are the advantage of GRE, but GRE disadvantage is that it has no encryption and it is only point to point like we discussed in previous one. So that is means we also have to create the tunnels here for every single branch office. So n into n minus 1 upon 2 tunnels will be there. The same concept will be for the GRE tunnel also. The basic GRE tunnel is also a site-to-site VPN with IPsec. So in the same way, the no encryption will be there for the basic GRE tunnel. We have to provide the encryption. Okay. It is a point to point only. That is means one tunnel only support one destination. We cannot dynamically create the tunnels. Like I told you, n into n minus 1 upon 2 tunnel will be required. Like 10 branch offices required 45 tunnels. So that will be a big number as I previously told you. So if we have many branches, we have to create many tunnels. Now let's talk about IPsec over GRE. Okay. The problem is that encryption will be there. Also, it will support the dynamic routing protocol when we configure IPsec over GRE. The combination of both of them will create both encryption as well as the multicasting. That is means protocols will be supported. The multicast protocols are EIGRP and OSPF will be easily supported over here. But the problem is that we again have to create too many tunnels or branches. It is not scalable. We can't do that longer configuration on bigger networks. The CPU utilization will be high because we will create the encryption for every single tunnel. That is why CPU utilization will be really high and it is not easy to manage because there will be lots of crypto maps, lots of ACL, and also the troubleshooting will be very, very tough in this kind of scenario. Okay. We already told you that total tolerance will be n into n minus 1 upon 2. Okay. Like for the 100 branches, if we have 100 branch offices, we need to create 4,950 tunnels, and that is not possible to manage these thousands of tunnels separately. Okay. What is the solution of all of these problem? The solution is only the dynamic multi-point VPN, DMVPN. Because in case of dynamic multi-point VPN, only one interface tunnel is required on the source side and the dynamic tunnel can be created. We can create as many as tunnel possible on the destination side. Also, it's by default support the dynamic routing protocol. This means multicast. Multicast is supported. If anyone is not aware about the multicast here, please go through my EIGRP video as well as the OSPF. I explained the multicast very well. It also support encryption. It is scalable for the large networks. Okay, now let's talk about the further. So this is how the hub spoke works or DMVPN works. Dear, this is my branch office number 1 and this is 2, 3 and 4. So I don't need to create the 6 different tunnel over here. But what we will do, we will create a hub for the one branch and other will work as a spoke. So we can create the tunnel dynamically if the exit interface of the tunnel on the spoke side is not needed to be static. Only hub IP is needed static, so we can create hundreds of sites using one logical interface. That is means the hub should be static and we don't need the static IP addresses on the branch side. So branch side can be configured dynamically. We only need to configure the hub statically, and then with the help of this, we will provide some kind of policies over here, and dynamically we can create the tunnel on any destination irrespective of what the IP address is dynamic or static over there. So the we can see that less number of tunnels will be created. So in this kind of problem, we can dynamically create three or four or five any number of tunnels, and we don't need to reconfigure branch one every time. What we can do if we want to extend our network, like branch number 6 I want to connect, or branch number 5. So when we connect the branch number 5, so we need to do the configuration only on the spoke side. We don't need to do a big complex configuration on the hub side. So as many as uh, exit interface we can create with the help of the dynamic multi-point VPN. So dynamically we can create the spoke. We don't need to configure the hub every time. So this will work as a head office, and these are the branch sites or spoke sites. Okay. Now let's talk about the definitions of DMVPN. So as I told you that DMVPN is the multi-point virtual private network that allows multiple branches or site to connect securely through a central hub router while dynamically creating the tunnels between the spoke as required. I told you that the hub is a central is the central hub router which will create the tunnel dynamically, that is used to create the tunnel dynamically in between the spoke if required. Okay. So there are basically some technologies like multi-point GRE. It's not the GRE, but multi-point GRE. Okay. NHRP protocol, IPsec, we already know very well. So these are the new terms over here. So in our next video, when we discuss about the DMVPN, we will discuss all that. So this design is commonly used in enterprise wide area networks to connect many branch offices efficiently. Okay. So the DMVPN is the best solution of the above problem. Like one tunnel supports many peering. That is means single tunnel can have multiple exit interfaces with the help of MGRE. NHRP discovers other spokes dynamically. So NHRP is a protocol that discovers the spokes dynamically. Okay, IPsec provide the encryption. Now, let's summarize all the technologies like IPsec site-to-site VPN doesn't support multicast. That is means it doesn't support the routing protocols. Only GRE can support the multicast, but no encryption is there. When we combine both GRE over IPsec, it will it will create the VPN now. So when we do the configuration of IPsec over GRE, the VPN will be automatically created. But the problem is that the tunnel will be number of tunnels will be too high. So all of these problems will be solved by a single solution, that is DM VPN. So in our upcoming class, I will upload the DM VPN. Okay. So stay connected everyone. Please subscribe my channel and share to your friends. Have a nice day.